Just a quick introduction to the four categories of polymer. Polymers, as you know, are one of the three main categories of material. They are not plastics. Plastic is the technical word that means it can change shape. Metals can be plastic. If you heat a ceramic up hot enough, it can be plastic. If you heat up some polymers, they are not plastic and they burn, a particular family called the thermosets. When you are talking about the categories of material, you do not talk about plastics, you talk about polymers. Four main categories: thermoplastics, thermoheat, plastic, changes shape. When you heat it up, it changes shape, also known as thermosoftening. Heat it up, it softens. They are made of long chains that slide past each other when they're heated. When you cool it down, they're locked together by mechanical interlocking and van der Waals forces. So they heat them up, they change shape. Cool them down, they're rigid. The best analogy is a bowl of spaghetti. If I get a big bowl of long chain spaghetti and boil it up, it's soft, I can form it into whatever shape I want. If I leave it out for 4 hours for it to cool down, it locks together as the chains turn rigid. And the van der Waals forces, in this case, all the substance that comes out of spaghetti, I can't remember what it's called, locks it together. That's a good analogy. Thinking thermoplastics or think polymers, think long chains of spaghetti. Thermosets, the second category, heat them up, they stay rigid. If somebody's set in their ways, they don't change. A thermoset, when you heat it up, it doesn't change. They're a three-dimensional rigid network. If you throw this video over to HD, you can see the red dots I've drawn in that, indicating the red dots are the crosslinks. At the atomic scale, every single many, mer, unit, many building blocks. Every mer has got a chemical bond in it. So every 4 to 6 atoms, there is a chemical bond in the thermoset chain. So the atoms cannot move. Once you make the polymer, it is rigid, it is fixed. Once you heat it up, or when you heat it up, it stays rigid and fixed until it burns or it chars, or it decomposes in some way, shape or form. Thermosets, elastomers, are long flexible chains that is tied together loosely. Not as many bonds. Best analogy for the thermoset is once again that bowl of spaghetti, but now you get bored and you get a roll of cotton and you tie every single chain or strand of spaghetti together at random intervals like 2 millimeters apart, and you make sure everything's tied to multiple chains. Now when you boil that spaghetti, it's going to stay in the same shape. When you cool it down, it's going to stay in the same shape and nothing's going to separate it. Thermosets. Elastomers are long chains that are lightly cross-linked. So when you stretch them, the chains, because they're flexible, they can straighten out to a point until the cross-links. And straighten the cross-links, don't let it go anymore, and then it stops stretching. When you let it go, it returns back to original shape because of the crosslinks. Stretch it, let it go. Elastomers. Most common one is natural rubber, synthetic rubber. The crosslinks are sulfur. In the silicones, as in silicon rubber that you see the plumbers use, the crosslink is oxygen. Elastomers. The fourth category are natural ceramics. Wood. Wood's a natural ceramic. It's cellulose. The cells are made up out of cellulose, hence the name, and they're bound together by a natural polymer called lignin. So wood is a natural polymer. Keratin, your fingernails. I was going to point to my hair, but there's something missing. Fingernails, hair, animal horn are made out of keratin. Keratin is a thermo-softening polymer. When you heat up animal horns, they change shape. Not that I'd recommend you do that inside because it smells. But when you heat them up, you can change shape and you can form them into spoons, into forks, as our forebears did about 4,000 years ago. They are the four categories of polymer.